Let's settle this once and for all. Advanced aliens did not travel across the universe just to stack heavy rocks in the desert. Believing in science fiction is easy, but the real story is a massive engineering success. You are looking at millions of tons of solid stone. Attempting to drag that weight across miles of dry, loose desert sand creates a friction barrier that even thousands of workers couldn't overcome. On dry land, the physics of this project simply don't add up. The equation changes entirely when you add water. Modern radar satellites scanning beneath the sand recently revealed a hidden geological feature, the lost Aramat branch of the Nile River. Thousands of years ago, this massive waterway flowed directly alongside the Giza Plateau. Ancient builders engineered deep artificial canals, large basins, and stone docking harbors connecting to this lost branch. Massive wooden cargo boats carrying giant blocks could float from distant quarries across Egypt and dock at the very base of the plateau. Establishing this water infrastructure reduced the human labor required by 80%. This logistics-first approach turned an impossible desert trek into a high-capacity delivery system. Before stacking a single block, the workforce had to solve a site preparation problem. The original ground was a huge, uneven rocky hill. If the foundation tilted by even a tiny fraction, the entire structure would lean and eventually collapse as it grew higher. They had to create a perfectly flat surface. This diagram shows how they did it without modern leveling tools. Workers carved a connected grid of shallow trenches into the bedrock and poured water into them. Because fluid naturally creates a perfectly horizontal plane, they marked the waterline on the trench walls, drained the liquid, and chipped away the rocks sticking above those marks. With a flat floor ready, they had to align the 4 base sides to the cardinal directions. A surveyor planted a vertical pole in the center of a circle. By marking where the sun's shadow touched the circle's edge in the morning and afternoon, they drew a perfect east to west line. At night, they watched specific stars rotate around the celestial pole to lock in true north with near-perfect accuracy. Extracting the actual building materials required a mastery of physical pressure. To carve blocks out of solid limestone, they hammered dry wooden wedges deep into slots in the quarry wall. When they poured water over the wood, the dry fibers absorbed the liquid and swelled. This expansion cleanly snapped huge blocks free. This image shows a massive, unfinished block of ultra-hard red granite. Soft copper saws alone could never cut through this dense material, so workers poured champ quartz sand underneath the metal blades. The metal saw moved back and forth, dragging the hard quartz crystals like microscopic teeth to grind through the solid rock. Ancient builders bypassed their lack of advanced tools by utilizing the natural properties of water expansion and crystalline friction. Moving the cut blocks from the docks to the base presented another friction problem. Pulling heavy sledges causes the front runners to dig into dry sand, like a miniature dune, stopping all momentum. They solved this using soil mechanics. A worker stood on the front of the moving sledge, pouring small amounts of water onto the path. When sand grains get slightly damp, water molecules create microscopic bridges, binding the loose sand into a stiff highway and cutting friction in half. Civil engineers have pointed out a fatal flaw in the theory of a giant exterior ramp. A straight ramp tall enough to reach the 480-foot summit would require more material than the pyramid itself and would collapse under its own weight. This 3D wireframe reveals the actual solution, an internal ramp system spiraling upward inside the structure. To turn a 2-ton stone sled around tight 90-degree corners, builders left the 4 corners open, like flat balconies. Workers pushed the sled onto the open platform, used wooden levers to pivot the load, and sent it up the next straight tunnel. To ease the physical strain, they installed counterweight systems in sloping central hallways. This design allowed falling weights to slide downward on a track, automatically pulling rising stone blocks upward with far less human muscle. The most dangerous engineering challenge lies deep inside the pyramid, the king's chamber. This hollow room was built directly underneath millions of tons of crushing stone. If you place a flat stone ceiling inside an artificial mountain, downward gravity will eventually snap even solid granite in half. To prevent a cave-in, engineers designed 5 hidden, empty compartments directly above the flat ceiling, topped by a massive triangular roof. This pointed roof acts like a stone shield. The triangular slope catches the downward force and redirects the pressure safely outward into the thick surrounding walls. Ancient engineers survived these impossible structural constraints by taking gravity and carefully managing its direction. The logistical coordination required to pull off these feats dismantles the myth of a slave workforce. There were no millions of chained slaves being whipped across the desert sand. Archaeological evidence reveals a massive, planned city right beside the construction site. This was a highly structured residential town, featuring clean water systems, large communal dining halls, and industrial bakeries built to support over 20,000 workers. These workers were skilled, valued citizens. Excavations show they ate a high-energy diet of beef and sheep. Skeletal remains found nearby show healed fractures and evidence of delicate surgical procedures, proving they received expert medical attention and paid resting periods whenever accidents occurred. Look at the visual contrast in this photograph. The weathered brown steps are just the inner skeleton. To finish the monument, builders wrapped the entire exterior in an outer shell of pure white Torah limestone, polishing the blocks to a mirror shine as they dismantled the ramps from the top down. When completed, the Great Pyramid was a blinding desert mirror. Under the intense Egyptian sun, the smooth white limestone reflected sunlight across the entire valley, making the monument visible from dozens of miles away. The Great Pyramid stands as a masterpiece of human coordination and physics. A story that demonstrates the reality of our past is a more compelling achievement than the myths we use to explain it.